Okay, this is geometry 4.4. Proving triangles are congruent by angle, side, angle, and angle, angle, side. I think there's actually 4 boxes, so I'm going to erase that right there. I think there's actually 4. Okay, so the first thing that we're going to cover is the angle, side, angle congruence postulate. Okay, here's what it says. It says if angle A, so this angle over here, angle A in this triangle, is congruent to angle D, and side AC is congruent to side DF, and angle C, this angle over here, is congruent to this angle here, then that's enough to say the two triangles are congruent by angle, side, angle. So notice that the side has to come between the two angles. Okay, so there's the side. It needs to come between the two angles. It needs to be angle, side, and then angle. So here's an example, a proof that we're going to do for angle, side, angle. Here's this picture I have, and it says given that AB is parallel to DE, and I have drawn those in by these little red triangles. And you know that BC is congruent to EC. You got to prove triangle ABC is congruent to triangle EDC. And we're going to prove this by angle, side, angle. And so here's what we know. Right? So for number 1, we know that AB is parallel to ED, line segments, and that's given to us. Now because of that, we know that this angle here, angle B has to be congruent to angle E because they are alternate interior angles. Alternate interior angles. So far I have one angle that I'm trying to get. I'm trying to prove angle, side, angle. So I'm going to try and prove it in that order, angle, then side, and then angle, if I can. So number 3, I need to get the side. Well, the side is BC. It's been given to me. So BC must be congruent to EC, and that is a side, and that's been given to me. So I got that one down. So now I have an angle, then a side. So the last thing I need is an angle. And the last angle I'm going to get is going to be right here. Angle C, or angle BCA, should I say, make it a little bit more. Angle BCA is congruent to angle DCE. DCE, and that is an angle, and the reason that is true is because they're vertical. And we know that vertical angles are congruent. So therefore, check this out. I have now proven in my proof angle, then side, then angle. So I have enough information to show, okay, triangle ABC must be congruent to triangle EDC, and the reason is by the angle, side, angle congruence postulate. Congruence postulate. And there you go. So there's the proof for using angle, side, angle. Then we talked about the next congruence postulate, which is called angle, angle, side. So this is the last congruent postulate that we're going to talk about. Actually, this one's called theorem. I should erase that. Congruence theorem. Theorem means it can be proven, so you can actually prove this one. So the angle, angle, side congruence theorem. Here's what it says. If you know angle A is congruent, so here's angle A is congruent to angle D. Angle C is congruent to angle F, so you have two angles and a side. So BC is congruent to EF. If you have all of those things, then you have enough to say that the two triangles are congruent by the angle, angle, side congruence theorem. I should erase this one here. This is a theorem. This is the only one that's a theorem. Okay? So angle, angle, side. And notice that the side has to be opposite one of the angles, right? So it's angle, angle, side. Okay, and here's a practice proof for that one. We're going to go angle, angle, side for this one and move it down a little bit. Here's what we're given. We know that angle B is congruent to angle C. So this is angle C over here. Can't see that. We know that angle D is congruent to angle F. So there's two angles, and we also know that M is the midpoint of DF. And we're trying to prove, which is not written down here, we're trying to prove triangle BDM. BDM is congruent to triangle CFM. So we're trying to show that this triangle highlighted in yellow is the same thing, is congruent to this triangle highlighted in green, and the way we're going to do it is by angle, angle, side. So let's start off. Number one, we know that angle B is congruent to angle C. That's an angle because it's given. We know, number two, angle D is congruent to angle F. That's another angle because it's also given. Okay, now we're going to say that M is the midpoint of DF, and that's also given to us. Now, because M is in the midpoint, that means that DM is congruent to FM, and that is a side. And that is the definition of a midpoint. If something is at the midpoint, then it has to be directly in the center or in the middle of the line segment, so it's equal distance from both ends. So therefore, check it out. I've got an angle, and a side. So that is enough information to say that triangle BDM is congruent to triangle CFM, and the reason is the angle, angle, side congruence theorem. Okay, so there's another example for the angle, angle, side. So make sure you put this one in your toolkit, angle, angle, side, and also put angle, side, angle in your toolkit. And I'll put my toolkit online for you too as well. Okay, extra proof here. Here we go. Students wanted an extra proof yesterday just to get some extra practice underneath their belts. So here's what we got. I know that FH is parallel to KL, and I have that highlighted with my red triangles there. And I know that GF is congruent to GL, so I have a parallel lines and I have a side, and I'm trying to prove that the yellow triangle is congruent to the blue triangle. And we came up with using the idea of going angle, side, angle. We can get this angle, angle F and angle L, because they're going to be alternate interior. It should be red. They're going to be alternate interior. We can get a side here because it's given to us. And then we can get angle FGH and KGL because they're vertical. So we came up with an angle, side, angle approach. And let's prove that right now. So number one, we're going to say that FH is parallel to KL. And that's just given to us. Now, because they are parallel, we know that angle F is congruent to angle L, and that is an angle. And the reason is because they are alternate interior angles. Okay, I'm going to get a side now. Since I'm trying to prove angle, side, angle, I want to see if I can get that side. So I'm going to say that FG is congruent to LG, and that is a side, and that was given to me. Alright, so far I have an angle I've proven in my proof. I have a side. I need the last angle here. So number 4, I'm going to say that angle FGH is congruent to angle LG. Is it K? I'll move up. Yeah, K. And that is an angle. So the reason that is true because they're vertical. And so now I have enough information in my proof. I've shown angle, side, angle. So I'm allowed to say, all right, triangle FGH is now congruent to triangle LGK. And the reason is the angle, side, angle congruence postulate. All right, great. Then we had some classwork. There it was. It's page 223, 1 through 6 all, and then 8 through 13 all. All right, there you go.